All right, let's take a look at some applications of vectors now. So take a moment to copy this down. So we're looking at boat A, which has position vector r sub 1 is equal to t times the direction vector of 30, 15. So you can see we're only given the direction vector there. What's implied is that it's really starting at the origin. So there really is a point of 0, 0 that it's going through. And the origin here I've labeled h. So that's where it's starting. So 1 hour after its movement, it's at this point, 30, 15. The next hour that goes by, so when t equals 2, so right here we have t equals 1. Right here we have t equals 2. So 2 hours into this boat's movement, we're at this point, and we can see the general direction that boat A is heading. Then we have boat B. It's passing near the harbor, and we're given a position vector for that. We're given an equation. So we know that it's passing through 55. Okay, so 50 is the x, all right, and 5 is the y. So that's, think of it as that's when t is 0, that's where it's starting, so to speak. Okay, maybe it was anchored, and then it decided to just start moving according to a direction vector of 10, 10. So you can see the general direction there. So let me back up here. This is t equals 0. And for boat B, this is t equals 0. And then if you put a 1 into that vector, you're going to end up being at 60 and then 15 for its position, right? Just do the 50 plus the 10 and then the 5 plus the 10. So we can see the general direction of boat B, all right? It has a different direction vector than boat A. So we are trying to find how far apart are the boats when boat A leaves harbor. So what we're really looking to find here is right here is where boat A leaves harbor. We're really trying to find this distance, okay, showing us how far apart they are when the first boat leaves the harbor. Well, hopefully you can see that this is really just going to be Pythagorean theorem. Okay, we can make a right triangle around this, okay, and boat B starts at 50, right, and that's the x, and then the y would be 5. So to find how far apart, we're really trying to find the distance or the length of this segment between those two boats. So we really just need to do Pythagorean theorem. So it's going to be 50 squared plus 5 squared. Again, this boat B is really starting at the point 50, comma 5 if we were to turn it into an ordered pair. Okay, that's this point right here when t is 0. And if you put 0 into that equation for t, it's going to wipe out that direction vector, and you're just left with 50 and then 5. So we're going to simply do Pythagorean theorem on that. And if we clean this up, we have 25, 25 underneath the square root, and that is going to give us 50.2, and whatever our unit is. Okay, maybe it's kilometers. Okay, so that's the distance between those two boats when the first one leaves the harbor. Okay. Okay, next question. We want to find the speed of each boat. Well, the speed, please jot this down. This is equal to the magnitude of the direction vector. Okay. So all we need to do is take a look at each vector's or each line's direction vector and find the magnitude of it. So for boat A, the direction vector is 30, 15. So we need to find the magnitude of 30, 15. And for boat B, to find our speed, the direction vector for boat B is, well, the vector is 10, 10. So we're going to just feed each of these into Pythagorean theorem. Alright, so let's go back here and just insert a unit of kilometers for the previous part. Okay, so our distance is in kilometers, our time is in hours. So when we do Pythagorean theorem to find our speeds here, it's important that you remember the unit. So these are both kilometers per hour. Okay, so 33.5 kilometers per hour and 14.1. So you can see that boat A is moving at a greater speed than boat B. Okay, so the big takeaway here is to remember that if you are asked to find the speed, then it is the magnitude of your direction vector. Okay? Okay, and finally, suppose we want to determine, will these boats ever collide? So assuming that they are not going to change their course, if they continue on at those direction vectors that are given, will they ever collide? Well, if they are going to collide, then that means there's going to be a time and a position where it's the same. Okay? So hopefully you're thinking, well, if they're going to collide, then I can just set these equations equal to one another and see if we have a common time. So, if we take the first equation of t and then 30:15, let's set that equal to the other equation, which, by the way, notice that they each have a t in here for time. Okay, this is a plus. And then we have our t. So we don't have two separate scalars like we saw in those problems where we were finding an intersection point. In these word problems, the scalar is going to be t for time. So if they're going to collide, then there's going to be a time value where this is true. So let's split this apart just like before. So we would have 30t is equal to 50 plus 10t. And our other equation would be 15t is equal to 5 plus 10t. Okay, so let's see what happens when we solve each of these for t. So as you can see here, if we solve these equations individually for t, we have different time values. So that means they're never going to collide, they're never going to be at the same position at the same time. Okay, so will these boats collide? The answer would be no. If we got the same t value, like t equals 3, that would mean that after 3 hours they'll be at the same position. Okay, this is showing that there is no time value where they'll be at the same position, so therefore they will not collide.